Hello everyone. Uh, in this recording, I will be talking about network management models. This is the first chapter of your course notes, and I will be using a set of slides, but in your case, you can refer to your course notes. All right. So, what is network management models? Well, let's start by talking about the network development life cycle. This slide in particular is not in your notes, but I think it's a good introduction to the course in general. So, in during the program, we have been exposed to a lot of protocols, a lot of technologies, um, routing, switching, wireless, wired, fiber, all of that. Um, if you look at the network life cycle in general, right? The network life cycle starts by first, you have to do planning. You have to design a network or think about how to build a network that satisfies certain requirements. And then you design it based on that plan or that vision. You may do some testing before you build a large scale network. You may do some testing either by using simulations. You are familiar with simulations, you have probably used it at some point, like different simulators and emulators out there you can use. You can build a prototype, a small scale network that you use it to test various technologies, make sure that everything works and compatibility issues and all of that. And then you do the implementation, right? Building the network. The whole thing, analysis, design, simulation, and implementation, could take few weeks, few months. It depends on the scale of the network, right? And then once you build the network, now you have to manage it. So managing the network involves monitoring the status of the network, and also could be you could be changing the configuration every once in a while. You may be adding users, adding servers, adding maybe VLANs, changing the configuration a little bit. But in general, the the network life cycle continues for years, right? So you build a network in few months and then you run it for years, and then at some point the networks start to get old, requirements change, so you start the cycle again, and you'll do the planning again, design, implementation, and so on. So the cycle continues like this. Okay, so if you look at it from this perspective, then this course, will cover both the design aspect and the management aspect and the analysis. So pretty much everything except the implementation and the simulation, right? So this course will cover the top part of the development life cycle that you see in the slides. Okay, and we will be talking mostly about the management first, and then we'll talk about the design. We could simply started the course by talking about design first and then management later. Um, I chose to use management first and then design because when we talk about design, we'll talk mostly about concepts and no technologies, while in the management part, we still talk about some protocols and some technologies. So I'm going to leave the design part till the end where we have covered every protocols, every technology that we need to talk about, and only focus on the concepts. All right, so what does a network manager do? Some of you will end up with a job related to network management. So you will be responsible for making sure that the network runs continuously. One of the motivations behind network management is trying to solve users' problems in the most efficient and the fastest way possible. Right? Um, I always use the example of cars, right, or any motor vehicle. You can run, if you are driving a car, you can drive a car without looking at the dashboard, without looking at any of the information that is on the display in front of you. Because the car needs an engine, needs fuel, and you can steer it. As long as these functions work, you can drive. But if something happens and the car stops working, then you have to troubleshoot the problem. And troubleshooting the problem without having any indication what the problem is, it is time consuming. You don't know, is the car running out of fuel? Is it an engine problem? Is it some kind of a mechanical problem or electrical problem? You have no idea where the problem is, and you will start troubleshooting or trying to figure out the problem by testing everything. If you have the dashboard in case of the car, you may see if you run out of fuel, you see the fuel gauge at zero, so you know the problem is running out of fuel, right? If you see um, some of the indicators, the cars now have indicators. If you have something flashing in front of you, engine simple means that you have an engine problem, and so on. So this will, if the heat gauge is high, you know that the car is overheating. So all of this will give you an indication of where to look, what is the problem, right? So in network management, we'll try to do the same thing. You can build a network without any network management, but you have a problem where, as the slide says, user comes, whether it's remote or not, the slide says remote, but a user comes to the office and try to turn on computer and log in to their usual server, and then they don't get anywhere. They cannot connect. So they complain to the network manager, you say, well, I cannot connect. In that case, well, it's same as the car problem. You have to figure out where is the problem, where it happened in the network, what is it, right? And what is the solution? All of this will be your responsibility. Now, if you have no network management, no dashboard, no monitoring, you will have a hard time figuring out the answer to these questions. If you do, if you have this information, then you will be able to figure out the problem a lot faster, right? So what is the possible thing that could have happened? You will be looking at, okay, is there any configuration in the network that changed before this user logged in? Did somebody make any change? Has the network management software sent you any notification about failure? Maybe one of the links went down, maybe it was over congested. Right? Was there any security issue, any security breach? Um, has any performance, maybe the CPU of the main router has gone high, so the router is super busy, couldn't handle extra load. So all of this could be achieved or could be uh, known by network management. Right? So luckily, or maybe not luckily, I don't know, it depends on your situation. A lot of these problems need a person to figure it out and solve it. I'm saying luckily because of all of this automation, we still need people who know, understand the network technology so they can fix the problems, right? In some cases, we need also automation to speed up the process. We need tools, we need techniques and recovery to figure out what the problem is and then recover from it as fast as possible. So we still need people, and probably people still need some tools that helps. In our case here, what we will be studying is the tools that will help you manage the network efficiently. Okay, so the general objectives of network management is we need to keep an eye on the performance levels. So as I mentioned in the motor vehicle example, you're driving, you're driving a car, you're flying an airplane, you're motorcycle, whatever the device is, you are continuously monitoring the performance. You are looking at the dashboard and say, well, um, is the engine running at certain levels? Is the heat or the temperature of the engine appropriate? Is the gas levels or the fuel levels in the tank appropriate? Right. So you are keeping an eye on the performance of your vehicle. If you don't have a vehicle, well, compared with you have a machine, your computer, for example. When you're using it, you probably every once in a while you want to check the CPU, the RAM, uh, how much disk space, hard drive space left. You keep an eye on these things every once in a while to make sure that your laptop or your computer is running correctly. If you feel that, well, you're running out of disk space, then you probably time to either upgrade the computer or add a new hard drive to your computer. If you are continuously having CPU um, utilization very high, you probably either using very consuming resource consuming software, or your laptop is getting old and you need to be replacing it. So the monitoring performance, you can have examples of this in many cases in our lives. One of them, well, when you are managing a network, you need to take a look at performance levels on a continuous basis. And when I say continuous basis, maybe not every minute, but you need to keep an eye on the performance. Also, there is a big overlap between network management and security, right? I think sometimes before people start paying attention to security, network management was the security, right? And one of those areas of overlap is monitoring the traffic type. So you will be, if you are responsible for network management, or you should be keeping an eye on what is the type of traffic going in your network. If you have a network that's supporting Windows applications and all of a sudden you have Facebook traffic, then probably one of the users is using unauthorized software. If you see games traffic in the network, okay, maybe one of the employees in the company is playing while they should be working, right? Some of this could be an indication of a security problem. What if you see a large amount of traffic going to a specific network that's not usually the type of network that users go to. Well, this could be somebody's trying to send unauthorized information to somewhere else, right? Which be a security breach. So we'll talk about anomalies later, right? And we saw some of that in the security course as well, so you know what the anomalies mean. If the network is supposed to provide or get a specific service level, then network management and monitoring tools will be able to detect or monitor these service level agreements. So if you are supposed to be getting a connection to the internet with a maximum delay of 100 milliseconds, and all of a sudden you are seeing traffic that takes 200, 300 millisecond delay, right? So you could be going to your service provider and saying, hey, we agreed on 100 millisecond delay and now I'm seeing this level. And I'm just giving you an example, but there are other service level agreements that may be applicable as well, including reliability, availability, um, bandwidth, also other things. One of the major objectives of network management is to detect failures as soon as possible, right? So the example that I mentioned before, where a user comes and tells you they cannot connect to the network, I always say, as a network manager, if the user comes to you and tells you about a problem and you are not already aware of it, you must be doing something wrong. You should be always able to detect the problem before the user does. Maybe this is a little bit harsh, um, and more demanding, but I think as a network manager, you should be on top of the network, and you should be, the ideal situation is a user comes to you and tells you about the problem, say, yes, I am aware of it and I am working on solving it. Or even in some cases, if there is a problem, you will be telling the users, oh, there is a problem, we detected a problem, there will be and we are working on it, so the users don't even have to come and talk to you about that. So another part of the objectives is to have a proactive maintenance, right? So if I see my drive is almost full, I should go and buy another hard drive before I run out of space, right? Otherwise, at some point, I will stop. I won't be able to do anything with my computer or laptop. With networking, all right, so we have resources and we should be able to maintain these resources. If the users are using 90% of the bandwidth to the internet, so at some point I can say, well, if this continues, and with the rise of the use of the internet and the cloud services and all of that, I may run out of bandwidth. So I better go and buy more bandwidth or add another physical link to the internet, or go to another service provider, or do something to expand the network. That's expanding. How about, okay, so I have this switch that has been running for 5 years, and now it may start, everything has a lifetime, so it may start failing soon. So I better go and upgrade it before it starts failing, right? So all of this is called proactive maintenance, which means that I am taking steps to maintain the network before failure happens. Another objective is to talk about or forward some of the tasks to a service provider or outsource support. So as a network management personnel, you're not supposed to, especially in large networks, you cannot manage everything, right? Either because you don't have the time resources or because you don't have the skills. So a lot of networks rely on an external resource for support. As part of your task or your job as a network manager is to maybe delegate or outsource some of the maintenance and support to somebody else. Right? Um, in many cases, we saw in security, for example, in the security course, that we need to comply with some standards and some regulations. Right? Who's going to do that? Well, as I said, there is a lot of overlap between network management and network security, and could be part of the network management is to collect and provide information for 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 audits. For example, somebody asks you to scan the entire network and provide you with a list of all devices in the network. This is actually network management task. You may have security people may have actually asked for it or want it, or maybe in the security course we said that's the security objective, but in a lot of cases that's also a network management job because they are the ones who are supposed to know what the network look like and which devices are on it, right? The last step is, or the last objective is streamlining network operations functions. This is mostly, how to change things, how to upgrade things. It's not, we'll talk about that when we talk about change management um, and other similar operations. If I want to upgrade the network, is this something that I can do in the middle of the day, or it's something that has to go through a process, right? So a lot of network operations need to be um, managed properly in a way that things happening all the time in the network, but they don't affect the user, right? So the job of a network management is to keep the lights on, right? Keeps the network running and be as well. You have to make sure that the network is always available to the users. Okay, so now we talked about network management. So what is the definition? All right, so um, this definition comes from different sources, and the sources were in you can see the sources in the reference section in your notes. Um, and I grabbed this definition from, as I said, multiple sources, but they tell me, I guess, the whole aspects of network management. So first, network management is all activities, methods, procedures, and tools that are related to administration, maintenance, and provisioning of network systems. Right. So that covers a lot of tasks. Right. So all activities and activities. You notice here that we're not talking about protocols. We're not talking about technologies. I'm not saying anything about OSPF or BGP or RIP or spanning tree protocol or any of that. No, the network management is everything, all activities, all methods, all procedures, all tools that has anything to do with the administration, maintenance, and provisioning of network systems. And that's why sometimes network management has a lot of things to do that had nothing to do with networking technologies at all, right? So, for example, purchasing a new uh, switch maybe going over the purchase procedure for the company has a procedure to purchase equipment, right? Budgeting. You need to have a budget every year for maintenance, and you need to use this when you buy hardware. This is part of the budget. You need to estimate the budget beforehand. You need to ask for money, right? So that's all part of activities, right? Uh, the methods of doing network management, the tools. This includes software. So all of this is part of the management. And that's why network management is a really big field if we want to talk about all aspects. And some of it um, goes beyond some simple, just networking technologies. Another part of the definition is network management is used to ensure systems effective and efficient operation within the allocated resources and in accordance with corporate goals. This part or this sentence tells me that network management has everything to do with not just running the network, but also running the network effectively and efficiently. Right? It's not just enough that I have resources, but these resources have to be um, efficiently used. And also, um, the network is an asset to the organization that you are or that uses this network. So you cannot just um, think about the network as something that um, isolated from the company's business in general. No, this is an asset. So the asset has to be allocated budget, has to be allocated some resources. You cannot just go and ask for the biggest and fanciest hardware. Well, no, this has to be related to the company's objective. Um, you buy something, you expect to make use of it, and you turn a profit if the company is a profit company or a company that's done business, right? Everything you do has to be part of the corporate goal. So far in all the courses that we took, we looked at only networking technologies, but now we are looking or we're saying that this network is part of a business. So it has to be integrated with the business. And you may find yourself as a network manager um, being restricted to certain amount of money, certain goals, right? You cannot just, what I'm trying to say is your decisions are not based only on technical matters, but sometimes you have to consider business objectives as well. Right? Part of your job, if you look at the top two sentences, is to um, control the resources, make sure that the resources are within limits. You cannot just go buy bandwidth as much as you want because you are limited with a budget. Right? You have to coordinate any network services, upgrades, changes, all of that with the business. So there are people who are using this network. So you cannot just go in the middle of the day and try to upgrade the router while everybody is trying to do business, right? Try to use the network. So it has to be coordinated. You have to see yourself as part of a bigger organization. Part of your task as well is to um, not just monitor the network status as we saw earlier, but also report that to higher management. So this is the network. This is how much resources we're using. This is the trends. These are anomalies that we detected, and you could be doing that in uh, regular fashion, like every week, every month, every year. Depends on what kind of reporting you're asking or you're asked to do. Okay, so the topic of today's or this recording is models, network management models. So we're finally getting to that point. So all the all what we learned about network management comes from certain standards, and we call them certain models. Right? They didn't come from nothing, and these models came from different directions or different sources. Some of them predates even networking. So some of them we learned from earlier communication before the data networks. We had phone networks, telephone networks. So they were running things back then. We learned some of that, some of the network management from that. We also learned from standards, different different standards. So what we will be talking about today is these standards where we learned network management from. And you see in the slide we have 4 different standards, and also we'll be talking about a different or a new approach to network management, which is the automation, right? So the first um, the first standard we will discuss is the OSI, CMIS, Common Management Information Service, and this is where the same source of information that we learned or we got the 7 layers of networking from, right? So we learned about the OSI model, the 7 layers. Well, the same folks who came up with that model came up also with a management model, and the management model is called, or it uses a protocol called the Common Management Information Protocol. Right? And it's defined by, as I said, by the ITU. That was, or this standard matches the OSI stack. We have another management model called the telecommunications management model. This was widely adopted by telecommunication networks, and it is similar concepts to the OSI, but it's not the same, right? And it's not compatible either. But you will see later that we have common aspects. So each one of them talks about network management. They're not compatible, which means that they're not like you cannot just mix and match them, but they have common grounds, including actually the TMN relies on the protocol, same protocol as the OSI model. We have the internet management architecture. This is not there is no standard called the network internet management architecture. I don't think so. It is what we have is something called the SNMP, which is the protocol itself, and it is the most widely used protocol in network management. It's simple network management protocol, and we will dedicate some time to talk about it. SNMP is the concept behind this. The SNMP is the internet management architecture. So again, it inherits or adapts multiple concepts from the top 2 standards. They're all related, right? And finally is the ITIL or ITIL, or it's pronounced differently. This is a collection of documents that mention best practices for not just network management, but for IT management in general, information technology management in general, right? And there is a big part of it related to networking as well. So we will be talking about all four in this recording. Okay, we'll start with the OSI framework. So what is it? Um, the OSI came from the International Organization of Standards, or in particular the ITU. Well, the ITU and the ISO are not the same, but they are related anyway. Both are international organizations. uh, it divides the network management into four different models: the organizational model, the information model, communication model, and the functional model. Right? And each one of them look at network management from a different perspective. So the organizational model deals with the components. So it tells you, if I want to manage something, well, I have to define what that thing is, right? So it defines the components that are part of the network management. So what are the components? So you see here that we have something called managed elements, unmanaged elements, agents, stations, or managers, and management databases. Right. So these are the components that are defined by the OSI. You can see here the definition of each one of these, but what I will do here is to just stick to the slide, and I will explain each one of these parts. So you'll see here, we'll start with the managed element, right? So the managed elements is the device that you are managing, right? And this device, from your perspective, can be a switch, can be a router, can be a server, can be a firewall, any device. And actually, the network, the management or the organizational model here may not be limited to only networking. It could be anything, right? It could be your TV, if your TV can be managed, right? The other side of things is the management station. The management station is where you have all the tools that you need to manage um, your network. Okay, now in both in the managed element and the management station, you are connecting two computers together. They're not going to start managing each other. You need software, right? So and the organizational model here talks about an the model that uses agents. Right? We'll see at some point in this course that we have agentless or agentless management. Um, but with this type of management, we have an agent. So an agent is a piece of software that sits on the managed element and talks to the manager. Another piece of software that sits on the management station. So the agent here collects the information from a managed element and send it to the manager. The relationship in this case could be the manager polls the agent, so it asks the agent for information, right? but not necessarily always the case. It depends. Sometimes the model asks for, the manager will be polling or asking the agent for information. Sometimes the agent sends the information um, voluntarily to the manager. And you will see both cases used in network management. The way they communicate, because we're talking about networks, so the way they communicate with each other is through a management protocol. The management protocol is the communication vehicle, right? It's not by itself the purpose of network management. It's just it carries information from the agent to the manager. So what is the information that we need to carry, right? In the OSI model, we have something called managed objects. You will see them here. So what are the managed objects? All right, so in the car, the example of the car, we need to look at the temperature of the engine. We need to look at the rotation per minutes of the engine. We need to take a look at the fuel level. These are the things that we need to keep an eye on. In networks, what we need to keep an eye on is the bandwidth of certain links, whether the link is on or off, how many bits per second passed or how many packets passed through a specific port, the number of active ports on a switch, some environmental objects like the environmental, like temperature, the speed of the fan of the switch, some other parameters like how much memory left on the main gateway, main router, what is the CPU utilization level of the CPU. All of these we need to look at them to get a complete picture of the health of the network, right? So a switch, for example, may provide us with the status of each port, how many packets passed through that port, how many packets received through that port, um, whether the port is enabled or disabled, administratively enabled or disabled. All of this is, we'll call them managed objects, right? So the agent collects the information from the managed objects and send them to the manager. The manager may need a database to store some of this for historical records, right? So the manager may need the person, not the device, the person, the network manager, may need to look at the bandwidth over the last 6 months to see a trend. So in that case, the software manager, the piece of software here, will maybe collect information about the bandwidth from devices every 5 minutes and store them in the management database. Later on, the network manager, the person, will use maybe other tools to graph the information and get a nice picture of the bandwidth used in the network for over the last 6 months, for example. Okay, to complete the picture, we have something called unmanaged element, right? So in the organizational model, since we defined everything, we also need to define the devices that cannot be managed. And in this case, what are the devices that cannot be managed? These are any device that does not support this model. They could be routers and switches as well, right? But if the router and switch does not support this model and supports something else, or cannot be managed at all, then we call them unmanaged element, right? So let me explain here. Let's say you have a network that's made out of Cisco devices, right? These devices, as you will see in the lab, for example, can be managed by a protocol, simple network management protocol, SNMP. An SNMP can be used to monitor all of this information that we talked about, CPU, fan, port, all of that. And then you go to one of the stores here in Halifax and you go buy a switch that doesn't support SNMP and you plug it in your network. That switch could be managed uh, by logging into the device through an HTTP protocol. You can go, you have a web interface, you can turn on and off the ports in it. You can configure VLANs, you can do a lot of things, but it's not SNMP. In that case, from the perspective of SNMP, that switch that you bought is not manageable. It's unmanaged element, right? So this is important to make sure that you understand this is unmanaged element. This is from the perspective of this organizational model. You can still maybe manage this element in a different way, but not using this model, right? And there are actually some devices that you cannot manage. They are passive. They don't have any management interface whatsoever, any management. So that's possible too. Um, some media converters, for example, a media converter is a device that looks like a bridge. It's a bridge. It has two ports, one fiber, one copper. So you can plug fiber from one side, you copper from one side. So we call them media converters because they convert between fiber medium to copper medium. But they may not be managed. So you buy them. That's the only function they do. You plug a device, you plug a cable here and cable here, and that's it. You cannot manage it. You cannot look at it, right? You cannot, for example, see how many packets pass through that device. All right, so that example of unmanaged, totally unmanaged elements, so you cannot manage them in any ways, right? And by the way, some media converters can be managed as well. All right, so these slides have a description of detailed description. So of course you can rely on your notes to find the description, the detailed description, and it's actually better than these slides. All right, so the organizational model also described the relationship between these components. So we saw one type of relationship, which is this one. So we have one management station, one managed elements, and these gray areas represent the software that we use for management. We will call that model two-tier organizational model. All right. And why? Because we have, of course, the manager does not just manage one element. That's not efficient in a large network or even a small network. There are multiple devices that you need to manage. So we have here these devices, and for completeness we added also unmanaged elements. But these devices, they talk to a manager. So this is called the two-tier model. The first tier is the elements themselves. The second tier is the manager, right? And we can have, of course, multiple elements. If the network becomes bigger, a single manager may not be efficient or possible to manage a large network. So now what we need to do is to move on to a three-tier organizational model. So a three-tier organizational model will divide the network into segments. Each segment have a manager that manages multiple elements, and then that manager, but is at itself is a managed element to another manager, right? So we will have, if I can show you quickly what I mean here. So let's say we have a large network, and that network consists of multiple devices. We can assign a manager to each one of these networks, and that manager will talk to the managed elements. And then these managers, they talk to another manager. So from the perspective of this red manager, these are managed elements, and this is the manager. From the perspective of the green manager, this is the manager, and these are managed elements. Okay, so now we can scale this network in much larger scale. So imagine multiple buildings. Each building will have its own network manager, and then the organization in general has one manager that talks to all these building managers. Right? The standard or the OSI model does not work in a peer-to-peer fashion. There is always manager and agent, right? So we don't have a peer-to-peer. So that's why here, this middle manager that we see has a manager software that talks to the agents at the bottom and has an agent software that talks to the manager at the top, right? So it has two pieces of software. So it acts as an agent in one side, and it acts as a manager on the other side. It says here in the slide that, as an example, there is a remote monitoring agent, or one of the examples is a remote monitoring agent, or RMON. We will see that in the next recording, in the next lecture. The idea here is, in some cases, we have a network that has a LAN, for example, and the LAN consists of multiple devices. We can assign a network manager that deals with only monitoring the LAN, not anything else, right? And then all of these LAN managers talk to this green manager, which could be a server somewhere in the network. I didn't connect it to any LAN here, but it could be connected to one of the other LANs. So one of the protocols that we will look at, it's called RMON, and it works in the same way, right? RMON is not an OSI model; is actually part of the or extension to the SNMP protocol, but it works as an example here. Okay, there is also something called a manager of managers. And the manager of managers works the same way as this one. And in your notes, you will see the diagrams are similar. Here I have a smaller diagram, but in your notes, you see the diagrams are quite similar to each other. So what's the difference between a manager here and the manager of managers here? The difference simply is the type of information that the manager of managers or mom collects. So in this case, the top manager here may collect the same information as the small or the lower or the middle tier manager. So it may still collects um, uh, all the detailed information, packets, CPU, temperature, all of that. It may still collect all this information. It's just that relies on the middle tier managers to collect information first and then maybe send them in bulk to the top tier manager. Here, the manager of managers actually it doesn't collect the same type of information. Instead, it may collect only aggregates. So only it may say, well, to the middle tier managers here, just give me an overall picture of the network that you are managing. What is the overall reliability of the network? What is the overall bandwidth that's used? So higher level information. So the higher level information may be used just by the administrators or the top executives in the company just to look at general information about the network, how much money we spend, right? What is the overall service level agreement um, adherence, right? So all of this can be the responsibility of the top manager. So think of it as just high level information rather than a collection of the lower level information that we gathered from the bottom. And finally, I said the organizational model doesn't have peer-to-peer. Actually, it says here there is the peer network management systems organizational model. We can do the peer by actually having a manager and agent on one side and a manager and agent on the other side, right? So the manager here talks to an agent on the other side and vice versa. So we can um, fake the peer-to-peer relationship by each device will be a manager of the other device and agent at the same time. When is this is useful? This is useful if we let's say we have two networks, each one of them has its own network management system, and we decide to integrate them together. Maybe two companies merge, right? So now we can connect one network management to the other network management and we share the information between the two. So we use this model. Another example is if we want two network management systems to work for reliability issues. So instead of one network management system, which if it fails, of course, we will lose any network management. So we have two of them. And to make sure that the two of them have a full view of the network all the time, we may connect them so that each one gathers information and share it with the other and vice versa. Right? And if one fails, the other one can have all the information and continues on. Right? So that's the organizational model. How about the information model? So the information model describes the structure of the information itself. Right? So I said before that we need to collect information about managed objects here and send them. Right? This information, if I'm talking about number of packets, the format of that is different than when we talk about temperature. The temperature, maybe I'll use a floating point number to send the information. If I want to talk about number of packets, I may need to send a long integer. If I want to send the status of the port, if it's up or down, maybe I'll send a boolean, right? Sometimes the information is string. So if I want to ask about the location of this managed elements, which could be one of the managed objects, is the location. So the location could be a string, could be latitude and longitude, right? Could be could be an address, right? So all of this is described by the information model. What is the format of all of this information, and what is the structure of the information itself? We will see later that we have a specific structure. So all of this information is organized in a specific database, specific structure. We'll say, well, it's a collection of all of this information, right? And we will talk about something called a management information base. For now, we're not going to go deep into this, but we will see later when we talk about SNMP is what the MEB is. And now you are probably asking yourself, but the SNMP is a different network model. We talked about OSI, NMA, or ITEL, or all of these models, and now you're mixing things and you start talking about SNMP, but we are still talking about the OSI, right? Well, these are overlapping, as I said before. Over all of them, the information come from different models, and they overlap. And the IETF, the Internet Engineering Task Force, when they created the SNMP protocol, they inherited or they used some of the concepts from the OSI model. Right? Same way in TCP IP, probably didn't throw all the layering from the OSI model completely and said, well, we'll start fresh. No, they used the same concept of the layers. Instead of, they still have data link layer, they still have IP layer and TCP layer, right? And the application. So they kept they inherited some of the information from the OSI. Same way here, right? So the third model is the communication model. And this model talks about how the information is exchanged between the manager and the agent, right? And this, if you want to look at it, talks about the protocol itself, right? So here, and as I mentioned before, the protocol, if you go back a number of slides, the protocol for the OSI is the Common Management Information Protocol. The protocol that's used by the IETF is the SNMP protocol, but the concept is the same, which is we need to have a protocol that allows us to send the information from the agent to the manager and maybe receive instructions as well from the manager, right? So that the communication here works or organized in terms of requests and responses and notifications. So I may go a step ahead and say, well, in the relationship between the manager and the agent, the manager sends a request and the agent provides a response. So all the messages are formed in terms of requests and responses. There's also another type of messaging. It's called notifications. That's when the agent sends a notification to the manager without the manager asking for it. And that usually to provide some kind of alert, right? All of these protocols will rely on existing protocols underneath them. So we may rely on TCP, we may rely on UDP. In some cases, we rely on the IP directly, right? So we will see how all of these work when we talk about um, specific protocols. And finally, we will talk about the functional model. So this is the fourth and final model. The functional model is actually divides or talks about we talked about all these technical things, but what they do, right? So what is it that they do? Okay, so we have manager, we have managed elements, we have communication between them, we have the structure of the information. We know this is a floating point, we know this is a string, but what are we doing? So the functional model says that the areas of management can be divided into 5 different functional areas. And these are very, very important. And this is one of the things that we will get from from the OSI model is this division of functional models. And I always tell students, you have to memorize these, right? You have to memorize this, and any if I am interviewing you for a network management position, I will be asking you to tell me about these functional areas. So the functional areas are fault management, configuration management, accounting management, performance management, and security management. The way I memorize them is the FCAPs, right? So FCAPs is the way. And we will talk about these in details in a separate lecture actually, and we'll talk about them in extensively. If I want to just give you a very quick introduction to these functional areas, so the fault management is all the activities that related to using network management to detect faults, only to detect faults, right? Configuration management is all the functions that are related to changing configurations and managing configuration, including, for example, making backups or monitoring configuration change. Accounting management, anything that's related to monitoring or measuring the utilization of resources. So I want to measure the amount of bandwidth used by a specific user so I can charge them money for using the management. Of course, accounting management doesn't apply to all organizations, but if you are a cloud service provider and you are charging the user for how much bandwidth they use to connect to their infrastructure, then you have to monitor that because you want to charge them for it. Performance management is all the activities and measurements that you need to have to measure performance. And performance here, the definition of performance changes. So, or depends on what is your what are you looking for. For example, simply if I want to monitor the performance of my printer sitting next to me here, So I may be looking at the toner or ink level, right? And see the ink level because this is the performance, or how many papers printed so far, because I know that at some point I need to, well, the lifetime of the printer is not infinite, so at certain level of ink it will stop and I have to replace the ink. At certain level of papers I have to stop and replace some of the components to keep it working. Networking, same thing, right? There is a I need to monitor the bandwidth. I need to monitor how many packets dropped per second, so to detect how good the network is functioning. I need to monitor the CPU level, the RAM level, all of this. So I want to monitor the performance. And finally, the security. And this imply or includes all the measures that I do to secure the network resources themselves, right? Passwords, um, authentication, um, restrictions of access, um, managing who does what. So I think all revolves around access levels and authorization and authentication. Right? And this is where security, as I said before, security and network management overlap, and they overlap in almost all of these 5 areas, right? Um, there is an overlap between fault management and security. There is an overlap between configuration management and security. And obviously, there is an overlap between the security management. And we can see the security management here as the part responsible for securing the network itself, while probably when we talk about security in general, involves also securing the data that moves along the network and securing servers and all of that. All right, so the other reference model or network management model that we use is the TMN, Telecommunications Management Network. And it is described by a set of standards, and they are the standards themselves are referred to M.3000. And as I said before, they're not compatible with the OSI, but they have similarities as well. So it divides the network management into layers, 5 layers in particular. At the bottom layer, we have the elements themselves. This is similar to the managed elements that we talked about. So here we'll call them network elements, right? So these are the switches, the routers, firewalls. Then the layer on top of that is all the tools that we use to manage a single element. So if we use a protocol, specific protocol to gather information from a specific element, well, that's now we are managing an individual element, right? So we use one protocol or we use a tool to manage one particular element. If we gather all of this information, we get to the layer, middle layer, the network management layer, and this looks at the network in general. So all the tools and protocols that manage the network as a whole, right? And of course, to manage the network as a whole, we need to manage specific elements. So we need to rely on the layer at the bottom, right? The service management deals with issues related to maintaining the service level. So it looks at the network from the user perspective. I don't know if the slides here, yeah, the slides here says, so it's concerned with the aspect that may be observed by the user. So the user may not care much about how many packets per second the port has has used, right? Or or what is the specific bandwidth. But from the user perspective, maybe they are concerned about latency. Maybe they're concerned about um, if they are watching a video, they're concerned about jitters. Same thing with phone conversations. So so the service management layer is concerned about things that the user uh, is sensitive to or can be um, can observe, right? So the temperature of the switch may not concern the user that much, but the latency concern the user. Availability of a link may concern the user because they may not be able to communicate if a link is down, right? Quality of service, which I mentioned as latency, for example, latency, amount of bandwidth, um, jitter, anything that's affects the user experience is part of the service management layer. And also, as we will see later, this layer may also include the tools that allow the user to notify the network manager about any failures, right, or troubles or any issues. And finally, at the top layer is the business management layer. So this is from the management perspective, not from the network perspective. So how much resources we used, the budget, uh, strategies to improve the services or add new services to the network. All of this is at the management, the business management layer. So you can see here in this slide, I didn't mention the elements themselves. So the elements are understood as the devices in the network, right? One common thing between the TMN and the OSI models is the FCAPS. The TMN also uses the FCAPS or also divides the general management functionality into 5 areas. And actually, TMN has probably more information, at least the document has some information about the FCAPS that not available from the OSI. All right, so how does the two are relating? So the TMN says that all the 4 layers implement all the FCAPS with the exception is the business management layer here. So if you want to relate the two, so we have the pyramid of the TMN. It has the elements, it has the element management, network management, and the service management and the business management. And if you look at the functional areas, so the functional areas can be drawn like this. So FCAPS, I think I added one more. Oh, the fault, configuration, accounting, performance, and security. Right. So there is an extra line, but so where the configuration management applies, it applies to all these layers. Where the performance functionality applies, all these layers, right? So that's what we mean by across all layers. All right, so the third model, and if you notice that I skipped the IETF model because we were going to focus on it more later. But the fourth model that we looked at is the ITL or ITEL. So the ITEL is a set of documents published by an organization. You have a link to it in your notes, and it also divides the practices or the best. So it's a collection of best practices, right? If you are in the IT business, you probably need to look at the ITIL, and there are actually certifications, ITIL certifications that you can take if you want to pursue IT management jobs. And it divides the ITIL into certain text. Each text has or describes related functions. So from the top to the bottom, we start with the service strategy, and the service strategy focuses on the strategic approach to IT services, or in this case, networking. So, as I said before in the first slides, we have a life cycle. Life cycle starts by doing analysis, by doing planning, and then by design and all of that. So that's the part where the service strategy is concerned. So planning ahead. So from a network perspective, what planning ahead means that, all right, in the future, what should I add, or how can I expand my network to support a new business for the organization? The network is part of the business asset, and it has to expand to support a new business. So if the company that you're working for starts to think about delivering a new product online and sell it online, for example, so you have to think about, okay, how am I expand my network to support that business? Or in another example, the organization wants to add new branches in different cities. So then you have to think about, well, how am I supposed to expand the network to include remote branches, right? And this is happen, of course, from the top level, from the strategy perspective, and then comes the next level, which is the service design. So from the network perspective, this means that actually designing the network, deciding what technologies we use, what hardware we use, what protocols we use, what is the bandwidth, all of that. So that's basically what the service design is concerned about. The service transition is relating to the implementation or the delivery of service. So the ITIL it talks about IT in general. So if you are, for example, looking at ITIL from the application perspective, not networking, but application. So service transition from that perspective means that, starting the application, scaling the applications, all of that. But from our network perspective, will just means that the implementation part, right? Installing, mounting the equipment, configuring the equipment, and also in the ongoing. So we cannot just, yes, we configure the network once, it may run for years, but every once in a while we may need to upgrade, we may need to change, we may need to add. So that's also part of the service transition. And we will talk about change management as well as part of that. And actually, the change management aspect of this course comes from ITIL mostly. Right? Then we have the service operation, which corresponds to delivering and supporting um, the IT services, or maintaining the level of service levels that we promised the the users, right? So the network is supposed to deliver a certain level of performance to users, certain level of quality. So service operation is concerned with that. And then we have the continual service improvement. If you look at the bottom two, the continual service and the service operation, that corresponds to our network management and monitoring, right? So we need to monitor the network, and we need to manage the network, monitor the network to make one of the objectives that we mentioned earlier. We need to make sure that we are meeting the customer expectations, right? And then the continual service improvement, this is anything that we need to change to maintain that level or improve it, right? So, and finally, the SNMP, which I left it to last. So the SNMP came from the Internet Engineering Task Force. It's more of a protocol rather than a management model, um, but it is widely used, and it inherits a lot of things from the top two, the other two at least, the OSI and the TMA or TMN. Um, so it is not by itself. We may consider it as a management model, but a lot of information that comes from SNMP is actually originated from the OSI and the TMN, right? So, what should I say about the SNMP? Um, It is originally, from the name, it was supposed to be for simple network management, right? Um, it was designed to be a simplification of the OSI model. As you can see from what we learned, the OSI model was very, very big and perfect, but also hard to implement. OSI came from the international organizations or international standards organization. A lot of companies and countries participate in that organization. So when they came up with something, they came up with a really huge thing, which makes it difficult to implement. So SNMP started saying, okay, we're going to get some of that information, but we'll implement it in a simple way. So they came up with the SNMP. But for many, many years, so I think the SNMP, the last version came in 1993, maybe we'll look at it later. But since then, it has been the dominant network management protocol. Lately, we will see that we have alternatives as well, but still the dominant network management protocol. And you cannot do real network management without it these days, right? Um, it has some flaws, of course, because it wasn't designed to do everything. So it has some limitations, but it's very important to look into it. Um, Even though I didn't mention it as one of the four main networking models, it's still very important to talk about automation. So now there are a lot of technologies that does automation. Automation, from the term itself, it's automating the configuration of the network, right? So and sometimes we use it also for monitoring the performance, but mostly for automating the functions of the network or the configuration. We have an issue with networking. For years and years and years, we configured networks by going to each device and doing it manually using the command line interface, the CLI. Right? Maybe things changed a little bit later and we start configuring the devices using HTTP, so we have a web interface. Each one of them is it's not good by itself, or it's not. So the CLI can allow us to do a lot of things, but every device has its own CLI. Different vendors have different commands. Even the same vendor, if you want to configure a Cisco switch and a Cisco firewall, you will see different set of commands. They look similar, but there is still some differences, right? If we look at HTTP or a web interface, it does not allow us to do a lot of things. It may be user friendly, but it doesn't allow us to do the some detailed work, right? So managing networks, one switch, one router, one firewall at a time, becomes difficult when we have a large network, right? And networking today, the SNMP and the CLI came when the network size was probably, if we have 10 switches, we have a large network, right? But now networking networks became very large, and managing the hardware using the CLI becomes exhausting and full of errors, and it's not practical. So we need a different approach. So the term automation is an umbrella term that means a lot of things, right? But generally means automating the configuration, and also sometimes automating the or collecting information, the status of the network, which is monitoring, right? So one idea came a decade ago, almost, is the software-defined networking. Software-defined networking in general, you know about it. We talked about it multiple times during the program, but in general means that remove the control plane, remove all or most of the intelligence from the devices, put it in one central location, and that central location sense of control instructions to all the devices. This is not much different from the manager and agent concept that we talked about, right? But the manager and the agent that we talked about, they don't, or they have a limited ability to change the configuration of the network or of the devices. You may be able to turn on and off a switch, but you cannot manage, you cannot use them to do a lot of things. SDN goes all the way and controls, like to the other extreme, and controls all the aspects of the network. So the hardware itself does not decide anything by itself. Everything comes from the controller, right? And we will see in the next slides, there are variations of this concept as well. Then we have another similar concept called intent-based networking. In this, the idea here is the network administrator tells the network what she wants to do, and then the network figures out how to configure itself by itself, right? So, for example, the administrator says, I want to build a VLAN between point A and point B, and give it certain access policy and certain quality of service, etc., etc. And the network figures out how many switches are involved in this configuration, what are the configuration um, commands that needs to be sent to each device, what are the access, the ACLs that need to be implemented, any quality of service measures needs to be installed. All of this is decided automatically by the network. Right? Another approach is we use some automation tools. So if you have traditional network that still uses CLI, still uses all the original technologies, but you still want to automate it, that's possible too. You can still automate those networks using many tools available right now, and we will talk about one of them at least in this course, which is Ansible, and we will use it in the lab as well. Right? So there are a lot of approaches that can fall under the automation models. So as I said, software-defined networking is one of them, and I put it here under network management model of this course because I think it is a network management paradigm. It is a network management model, and there is the original concept, right, which I just described. But there are also, after a while, people came up with different ideas where we can have software-defined networking, but not necessarily removing everything from the device, not removing all the intelligence from the device. So here is one figure that puts all these models together. So if we look at the most left picture here, we'll see this the original or the distributed model that we use in the traditional network. So you have a router. The router has control plane and data plane. The data plane is the part that's responsible for forwarding packets. So simply, when we talk about data plane, what we mean is the part that says, okay, here's my packet. I'm gonna look at the destination address. I'm gonna look up the table. The table tells me if I see this address, where to forward it next. And that happens whether we have a switch, whether we have a router, whether we have a firewall. Basically, all of them works at the same. The idea is the same. You have incoming packet. You want to forward it to one of the available other interfaces, right? Which interface? That is the data plane responsibility. And also in between you need to have a buffer, you need to have buffering, so the incoming packets maybe they're buffered, and then while the data plane looks up what is the next hub will be, and then the packet will be taken to the queue for waiting for it to be sent out, right? The packet may be dropped in the middle, so they may be dropped by the data plane because they don't have a destination in the lookup table. They don't have any entry that says where to forward the packet, so the packet will be dropped. Or if it's a firewall, then maybe the packet will be dropped because of a firewall policy, right? The decisions of where to forward this packet comes from the control plane. And the control plane could be you, could be as administrator. If you put a static route in the router, that you are basically the control plane. You put this manually. It could be from the control plane, could be from a PGP protocol, could be from an OSPF protocol, right? In that case, it is a distributed. So you know how all these routing protocols work. They talk to each other and they manage to decide on where to forward packets based on certain parameters. That's the distributed model. If we leave that distributed model as is, but we have a controller that manipulates the decisions a little bit. So OSPF decides based on shortest path and decides where to forward the packet based on the implementation of Dijkstra algorithm. But then the controller interferes and say, well, for this particular packet, forward it this way instead. So this could be called the augmented model. So we have everything traditional, but then we can interface with the routers and switches and change the behavior a little bit. This is possible if the vendor gives us an API, gives us an application programming or programmable interface. So instead of the device is a black box that I cannot access other than the original configuration, now I can go and maybe using software, I can manipulate the decisions a little bit. I can have the hybrid model, which allows the controller to either talk to the control plane or talks directly to the data plane. Or I can have the replace model. The replace model is the original software-defined networking concept, which is taking the control all the way out of the device and replace it with the controller. So everything happens using the controller. So now we have both extremes, and we have sometimes in the middle where a switch may be able to make some decisions on its own. For example, I can have the switch doing spanning tree protocol on its own, right, to prevent loops. But then anything else will come from a controller. So we have the hybrid model, right? So we have all these variations. Network automation in general, whether it's SDN or IBN or any of the other tools, helps in network management, and that's why we are studying it or talking about it today. It lowers the cost. Well, if you know how much time it takes to log into a router, configure the router. If you're doing manually, simple manual configuration, it takes a long time. Multiply that by how many routers you have in the network, that's a lot of time. If you do automation, that will reduce the cost, reduce the time, and then reduce the cost, reduce the effort as well, right? And reduces the chance of human errors because repetition is not something that the humans do very well, and they get exhausted, they make mistakes. Computers make mistakes, but when they make mistakes at a very rapid speed, but the general consensus is, well, once they figure out what if they do something well, they will do it well repeatedly as well. So I always smile or smirk at the idea that automation will eliminate errors. They don't eliminate errors. They may actually create more errors. Automation, you still have a human who does the programming. And if you're doing bad programming, well, you're just making problems at a much larger scale. But if you do the automation scripts or the automation application and test them well, and you know that they were working well, then they will reduce overall. They will do the good job and reduce the human errors. Increase productivity, because now as a network manager, you probably want to spend your time looking ahead, looking at designs, looking at how to improve the performance of the network, how to expand the network, focusing on business improvement. You don't want to spend your day configuring, right? Configuration is probably the least exciting part of the job. And once you do the configuration once or twice, maybe you get excited about configuring something for the first time. But when you do it over and over and over, right, you're not going to be excited about it anymore, and you would rather do something else. So automation will give you a chance to do other things. Um, um, you can also increase the visibility of the status or into the status of the network. So you can gather information about the network as well. You can gather the status of certain ports. If you do this in automation, you may be able to give a bigger picture of the status of the network with a script rather than doing it manually or even doing it with network management protocols. Okay. You can speed the process of deploying new services. If you want, as I said, the example, if you want to establish a VLAN or establish any point-to-point collection across the network, you can do it. If you do it automatically, you will be doing it much faster than doing it manually. So that's why we focus a lot on network automation in nowadays. And uh, during the lifetime of this course, the course moved from talking about SNMP as the most like SNMP was the network management course was all about SNMP 20 years ago. And over the years, the content of SNMP becomes smaller and smaller, and the part of network automation becomes bigger and bigger and bigger. So we'll see uh, in the next lectures um, some aspects of network automation, and we still need network network monitoring tools like SNMP as well. So we need to look into that as well. All right, so that concludes this recording, this lecture, and we'll talk to you in the next recording.